understanding psychokinesis. Psychokinesis, the term, implies that the mind influences physical reality. Consciousness, the mind, influences a state of a physical system. There have been, the phenomenon of psychokinesis has been examined and researched for many years. And in the more recent years, the experiments involve electronic random number generators, in which case the phenomenon is called micro psychokinesis. Well, I have to warn you because for some reason it takes some time from the time I start sharing my screen until the slides began to progress. At the moment, I'm experiencing this. The slides do not move to the next one. So I'm just saying things, waiting for it to start working. And it hasn't yet. It does it sometime. It is a problem of Zoom and PowerPoint. In my previous experience, it took 2 minutes before it started progressing. So I beg for your patience. So as I was saying, in the more recent years, the experiments of psychokinesis involve electronic random number generators or random event generators, and the experiments are called micropsychokinesis or micro-PK experiments for short. And what they're testing, the hypothesis they're testing, is that the statistical average of events generated by the random number generator will shift in the direction of intention by thought processes alone, that is, without the mediation of some brain-machine interface device, like the example I give you in the photograph. This hypothesis is a scientific hypothesis, a falsifiable hypothesis, because it can be proved wrong. There have been many successful micro-PK experiments published throughout the years. Perhaps the largest database of successful micro-PK experiments belongs to the Pear Lab at Princeton University. In the late 1990s, 3 groups got together aiming to replicate the large database of micro-PK tests from Pear Lab. It was, of course, Pear itself, and then 2 other groups based in Germany, one at the Gießen University and the other at the IGPP in Freiburg. The project materialized thanks to the initiative of IGPP Eberhard Bauer. However, at the end of this large experiment, none of the 3 groups could provide evidence to support the hypothesis of psychokinesis, and they published their negative result in year 2000. In view of this so unexpected result, 2 of the members of the Freiburg branch of this consortium, Emil Boller and Holger Bösch, joined by psychologist Dr. Fiona Steinkamp, decided to look somehow deeper into the problem of psychokinesis, and they designed a meta-analysis of psychokinesis experiments. So they started gathering studies to formulate their database by applying criteria for selection criteria. For instance, one criterion was that only studies in psychokinesis would be involved. By the way, the what they were aiming to examine was the correlation between direct human intention and the concurrent output of true random number generators. And naturally, one selection criterion was that only psychokinesis experiments were involved, not telepathy experiments. The other criterion, for instance, that only tests with true random number generators were involved, not pseudo random number generators. There was, however, a third criterion that they introduced in their selection of studies. You see, when they needed to combine diverse scores from diverse experiments, like experiments with dice, experiments with random number generators, in order to effectively combine these scores, they converted the scores of each study into a binary form, that is, into hit trials and miss trials. For instance, suppose there was a study of 100 trials, of which 55 were hits. Then the size of the study was 100, and the effect size of the study was 55%, the proportion of hits in the study. So they plotted the size of study against the proportion of hits in the study, and ended up with this diagram. I need to describe you certain characteristics of this diagram. For instance, for small studies, at the bottom of the diagram, the proportion of hits scatters widely. And then as the study becomes larger and larger, then the scatter of scores becomes narrower and narrower until it converges to a value which is the most representative effect size in the entire database. Well, what I have just mentioned is nothing more than the law of large numbers. However, there is another characteristic that belongs to this diagram, that on the diagram, the data should scatter symmetrically about the peak, provided there is a large enough database, that is. And this symmetric scatter of data, of scores, would be such so that if you work out the statistical average of all scores, the statistical average should coincide with the position of the peak. Now, all these characteristics give this diagram a special shape. It reminds you of an inverted funnel, and for that reason, it is called the funnel plot. The authors of the meta-analysis shared the files of the meta-analysis so that I was able to create the funnel plot of micro-PK data I knew. And here it is. The data that you see on the funnel plot are 380 micro-PK scores. And as you can see, I have also added two sets of curves, the blue dotted curve and the solid red curve. The blue dotted curve, as indicated, represents the 95% confidence interval curves, that is for random data, for independent data. And I was able to draw these curves on the basis of a standard equation in statistics. What is the meaning of these curves? Well, provided there is a large enough database, as the case here is these blue dotted curves should envelope the 95% of data on the plot and leave 5% of the data outside, provided the data are randomly distributed, they are independent from each other. Now, the 5% of the 380 is some 19 data points. But clearly, the data outside the blue dotted curves, the micro-PK data outside the blue dotted curves are far more than 19 data points. The funnel plot is broadened with respect to what it should be if these data were random, they were independent. And why do we expect independent data? Because these are the scores of independent studies. They should not be correlated in any way. So there is a wealth of information on this funnel plot regarding the mechanism of psychokinesis, and allow me to guide you through it. First and foremost, as you can see, the funnel plot converges to 50%. The most representative effect size in the entire database collected of scores collected over a period of 35 years, the most representative is 50% hits and 50% misses. That is, the micro-PK hypothesis is not supported. We would expect that the effect was shifted above 50%, and it's not. The mind does not influence physical reality. Then the next characteristic that we observe is that the plot, as I mentioned earlier, is broadened, which implies broadened with respect to the distribution of random independent data. In other words, the micro-PK scores on this funnel plot are correlated. Now, we don't know what is the source and the reason for their correlation. Well, we don't know yet. I'm going to explain that to you very soon. Third characteristic is that the scatter of data on the funnel plot is not symmetrically distributed about the peak. If you see on the right-hand side, the side where we expect micro-PK to be demonstrated and the hypothesis to be supported, there are more scores on the right-hand side, and the density of scores is higher. And on the left-hand side, the side of psi missing, there are areas void of data. And the problem is stronger for smaller size studies. You see here. The experimenters are simply not motivated to report the results of their micro-PK study because they did not support the micro-PK hypothesis. And by not reporting their scores, they simply biased the database. Now, the result of this asymmetry in data scattering is that if you take the statistical average of all data on the funnel plot, then it falls at 51%, which is statistically significant, corresponding to a Z-score of +5. Yet this statistical average does not really represent the true micro-PK overall effect, because it's false. It is the result of the unreported studies, those experiments that the experimenters did not report out of fear that they don't support their hypothesis. Ideally, imagine if 51% was representing properly the micro-PK database, then you have to imagine that this funnel plot was shifted so that the peak coincided with the 51%, and you have also to use your imagination how it should have been if the whole thing with the blue dotted curves was shifted towards the 51%, and that the blue dotted curves were actually enveloping the 95% of data. But this doesn't happen. We have an overall score, the most representative score, which is 50%, and a peculiar, weird, abnormally scatter, which is broadened with respect to the random distribution of data as they should have been. Well, the experimenters also shared the files corresponding to the control tests that the experimenters of micro-PK studies performed just to test the randomness of their processes, because they were talking about true random number generators here. And here I have also constructed the funnel plot of the control tests. They are only 137. The experimenters were not motivated to run randomness tests alongside their micro-PK studies. Let us have a look at the characteristics of this funnel plot, which also provides invaluable information regarding the micro-PK mechanism. I have, as you can see, plotted the 95% confidence interval curves, which they should envelop the 95% of available data. This database is relatively small, so we can't be too choosy with it. Now, the 5% of data that should be found outside the blue dotted curves, the 5% of 137 is some 6 data points. And I should start counting also not just the 1 point that I can see here, but also start counting the data points that lie on the blue dotted curves to measure 6 such studies. They are not outside. These scores of control tests don't really scatter as freely as expected, but we can consider it as adequate. So this database of control tests, we can consider it as adequate, although the scatter of data is slightly confined towards trying to be as close to 50% to prove that these results and these processes are really random. Let's have a look at the characteristics of this funnel plot. Yes, the plot converges to 50% because these are true random processes, of course. And as far as the 95 confidence interval curves, we can assume that they are okay, although we make a point that the scatter is slightly confined. And then there is the third characteristic. The plot is not, the scatter of data is not symmetrically arranged about the peak. Now, we see that there are areas void of data on the other side of the funnel plot, where the micro-PK, the successful micro-PK studies are expected to have their scores. And the problem of this asymmetrical distribution of data is stronger for small size studies. Apparently, the experimenters were not motivated to report the score, the result of their control test, out of concern that which was falling in this area here, out of concern that it might disqualify the random processes. But as you can see, suppose you have a study of control test of 100 trials. You could have yielded a score, a proportion of hits in that study of 52% or 53 or 54%, and this would not have disqualified your random process. But at that time, when these experiments were being generated, nobody knew about the funnel plot and how it could reveal the biasing attitude, the database biasing process introduced by the experimenters. As expected, the consequence of this asymmetry of data scatter yields an overall statistical average that now falls on the left-hand side of the peak at 49.5%, which is statistically significant, falling with a corresponding Z-score of -5. Now, having seen these two funnel plots and the characteristics, we understand that the processes that the experimenters have used to run the micro-PK studies are adequately good random processes. However, when they were running their random number generators, their processes under the title of a micro-PK study, the data, the scores became abnormally broadened. And the question is, why? Why is the micro-PK funnel plot broadened with respect to what it should be? Why are micro-PK data correlated? What is the agent behind their correlation? What has caused their correlation? I cannot reveal, there is the answer. I'm going to give you the answer very soon, but I need to introduce certain treatments, additional treatments to the micro-PK and control data. First and foremost, if you remember, we have just seen that the micro-PK hypothesis is not supported. The mind does not influence physical reality. And however, the experimenters are biasing the database. So a certain idea could be, we have to test it, that perhaps behind the broadening of data, since the mind didn't do it, and the experimenters have shown what they can do, perhaps the broadening of data is due to the some attitude of the experimenters. But I shall reveal that very soon. I have to subject the micro-PK data and control also test data to a certain treatment, because as you saw, the micro-PK data are now in binary form. And also they are biased data. They are not random data. So we need a model to describe their behavior, a model of biased binary data generation or state generation. I found this model, the model of biased binary states, in the book of the Austrian mathematician Richard von Mises. The book is titled Mathematical Theory of Probability and Statistics, and it can be found online. In order to give you a very quick description of the model, I shall go first to a binary process, which is random. Suppose that we toss a coin, a fair coin. Each face comes up at a probability of 50%, heads and tails 50%. Which face is going to come up after each tossing does not depend on what was the state, the previous state after the previous tossing, and it will not determine what is going to happen next, what state, what phase will come up. It's independent, it's a random process because this coin is fair. Now, we're moving on to the binary process, but only of biased states, because this is what we're interested in. This is the behavior of the micro-PK data. In the case of micro-PK, our two binary states is hit trials and miss trials. And according to the model that I'm going to show you, I was able to derive the confidence interval curves as a function of two probabilities, of two parameters only. Because these are, these are the self-transition probabilities, which I will call A and B. And of course, as probabilities, they range between 0 and 1. Why are they called self-transition probabilities? Because A, it is the probability of a hit trial to follow another hit trial. And B is the probability of a mistrial to follow another mistrial. So it's the probability of these things to occur one after the other. The state goes back to itself, and they are called self-transition probabilities for that reason. Von Mises analyzed the problem. I will show you a couple of pages from his book that he's working on this problem. And don't worry about that. I was able to expand and convert these mathematics so that I could derive the equations, the confidence interval curve for the confidence interval curves, especially for the case of micro-PK data. And the general equation is this one. Now, it might look a little bit complicated. I shall try to ease the impression a little bit. This Z0 is a standard parameter in statistics for random data for 95% confidence interval curves, takes the value of 196. But there are new parameters. It is this fancy capital P. This is going to estimate exactly where the peak of the funnel plot or of the confidence interval curves is going to happen. And it will estimate it as a function of the two self-transition probabilities. And then it's this other parameter, capital V, that this one will determine how the data on the funnel plot are going to scatter. And it is again a function of the two self-transition probabilities. So I have derived the curves that fit the confidence interval curves of correlated micro-PK data. And if I take these equations and fit them on the funnel plot of micro-PK data, I'm able to estimate the two parameters A and B. It's easy to be done. And I have done this, but I will talk about it in a second or a minute or two. Now, you might think, so what? You have estimated the confidence interval curves. You say you have estimated the confidence interval curves for that fit the micro-PK data. And how do we know that they are successful? You have just fitted the equations on pre-existing data, and then you worked out the two parameters. So what? Can you do it the other way around? Can you generate biased binary data according to the two parameters of your choice? Enough data as to build a funnel plot. And then on this funnel plot generated independently for these two parameters of your choice, and then see if the equations that you have, but the equations for the same two parameters on the funnel plot envelop the right amount of data as expected. If it is a 95% confidence interval, they should envelop the 95% of data, and so on. Good question, and I have tested it. And I have tested it to see that the equations were successfully enveloping the right amount of data, and I have 4 examples of it to show you. The computer program generated biased binary data, zeros and ones of various lengths. And after, say, 100, a length of 100, then several times. And then in each case, we were finding the proportion of ones or hits in the sequence, and then we generated a longer sequence and a longer, and we had enough data to make a funnel plot. And we made, I have made the funnel plots to show you for 4 different cases. As you can see, and I have plotted the blue dotted curves, which are the 95% confidence interval curves. As you can see, the self-transition probabilities of my choice was one that was much below 50%, one that was much above 50%, one that was 50%, and in all these 3 cases, the self-transition probabilities were chosen to be equal. And then in the 4th example, the 2 self-transition probabilities were not equal. One of them was favoring the generation of favoring the frequency of a hit after hit trial, whereas the where am I? The miss after miss trial was left at 50% in case in the 4th example. I will point out the characteristics on these funnel plots. When the 2 self-transition probabilities are equal of a hit after hit and a miss after miss, they are equal, the funnel plot always converges to 50%. Oh, sorry, this is the case where they're not equal. For case A, B, and C, the self-transition probabilities are equal, and the funnel plot always converges to 50%. If it is below 50%, the probabilities, then the scatter of data is narrow, shrinks with respect to the random data. When the self-transition probabilities are above 50%, then the scatter of data is broadened with respect to the self-transition probabilities, a case of micro-PK data. When the two self-transition probabilities are 50%, it's like generating random data here, and the blue dotted curves, the 95% confidence interval curves, adequately envelop the data, the 95% of the data available. What we also observe is that when the self-transition probability of hits are well above 50%, that is, this bias process is favoring hits and not misses, then the funnel plot has shifted above 50%, exactly what we would have wanted to be just to support the micro-PK hypothesis. And that is very weird. I don't know if you noticed, but this is extremely weird. Why? Because the experimenters biasing the database, they would have just favored hits. And then the funnel plot would have shifted to where it was expected. But the experimenters were biasing their database in a very weird way. They were biasing hits as well as misses. And this equality is the reason why the funnel plot is centered at 50%. And this is why the funnel plot is broadened. Actually, case C is a simulation of the micro-PK. See in the example here is a simulation of the micro-PK data. And in the case of micro-PK data, fitting this model on the funnel plot has yielded approximately that the two self-transition probabilities were 83%. That is, overall, if you consider that over the 35 years of experimenting, micro-PK experimenting, there was a mechanism of psychokinesis, an underlying mechanism of psychokinesis at work, and then overall and on average, across all experiments, a hit was following a hit and a miss was following a miss at 83% frequency. Now, this is very weird. We don't know at the moment, until it is revealed near the end of the show, that is, we don't know what has led the experimenters to bias the database in such a way, favoring hits by the same strength as favoring misses. In order to answer this question, I shall have to involve yet another analysis, subject the micro-PK data and the control data under another analysis, and this is the last one, I promise. But before I go to that analysis, let me say very briefly in passing that once I had developed the theory, the model, the theoretical model for binary, biased binary states, I decided to apply it yet to other natural processes, as for instance, to study to records of turbulence, to study their multifractal behavior. Nikitas Papasimakis was my graduate student at that time. His project was to develop the computer program that generated the binary biased states, and then also to carry out the mathematics of multifractal analysis. He's now a successful researcher and lecturer at the Southampton University. And I have applied the model to another interesting case. I have applied it to several cases, but this one is interesting because I applied it to two databases testing handedness in chimpanzees. There were two groups of chimpanzees, one living in the wild and one in captivity. So they were testing how the presence of human around was influencing the use of hand in chimpanzees. And I was able to provide a quantitative description of this effect. I mention it because the database is small and the studies in this database are very small as well. But still, I applied the model. I just wanted to show it as an example. Now, the other analysis of micro-PK data that I have introduced is called Rescaled Range Analysis on time series of natural records. I have created time series out of the 380 micro-PK scores and the 137 control scores. How did I do that? Well, simply by arranging the scores from the oldest to the most recent published, and for the micro-PK scores and for the control test scores. Now you might think, well, how could you do that? Some of these scores were published in the same proceedings of PA convention, so it wasn't really ideally possible. This is correct. There was a small number of them that I could not ideally arrange with respect to their date of publication for that purpose. But that was a small percentage of them. Overall, I could make a time series of both micro-PK and control tests. And then I applied the Rescaled Range Analysis on these two sequences. Before, in order to help you appreciate the analysis and the results, let me give you two examples. Imagine you have a sequence, a time series of monthly income of a person. This person goes through 10 years of prosperity, followed by another 10 years of poverty. You see, there is in the way the income changes from day to day, there is a persistent trend, regardless of direction, but there is a persistence. If you apply the Rescaled Range Analysis on this sequence, then you are going to estimate the so-called Hurst exponent, and H that will be found to be above 50%. We say that this sequence contains trends of persistence. In other words, we say it contains persistent long-range correlations. Now, there is another example I'd like to show you. Imagine that you ask a person to write down a random sequence of zeros and ones. Now, it is in human nature to alternate zeros and ones too much in order to produce randomness. So if the analysis is performed on such a sequence, then we will find that there are trends of anti-persistence in that sequence. The Hurst exponent that will be estimated will be below 50%. We say that this sequence contains anti-persistent long-range correlations. Of course, if the time series, the sequence of records is truly random, then the Hurst exponent will be 50% within statistical error. And of course, I have applied this method, this analysis, on the time series of micro-PK and control data. What does it mean? What have I found? Can you guess perhaps which of the two cases applies for micro-PK data? Here I have a graph of the Hurst exponents as a function of the length of the sequence. You'll see that the Hurst exponent estimated for the micro-PK time series and the control time series falls within the region, has values indicating the presence of persistent long-range correlations in the sequences. Well, I have to make a little bit of correction, if you allow me, because we don't really compare these values, these two values. This is the micro-PK for the 380 micro-PK data and the control for the 137 sequence of control data. But I will not really compare it with this line as a baseline simply because when one applies the method, the analysis on small size sequences, such as these two, then the Hurst exponent depends on the length. So what I did to overcome this problem, I went to a source of randomness in online, and I generated many sequences of random sequences of binary data, and I applied the Rescaled Range Analysis on these sequences many times for each length. The length varied from 100 to 1500. I applied it many times. I estimated the average Hurst exponent for each length and then the statistical error. So instead of this line as a baseline, I could use this one as a baseline to estimate the effect of the analysis on micro-PK time series and control time series. And still, it is in the region of persistent long-range correlations. What does that mean? Persistent. Well, what is happening? There, you see, when you arrange the micro-PK data per date of publication, they move in the same direction. If there is a hit published, a micro-PK hit, then it's more likely to be another hit coming up. Or if there is a micro-PK miss, it will be, the next one will be a micro-PK miss. There is a resemblance, a persistent trend in the sequences of the 35 years of experimentation. Well, you might wonder, is this persistence really the result of aligning, arranging micro-PK data per date of publication? Can we see if that is correct? If this persistence is due to the arranging of the scores per date of publication from year to year. Well, naturally, I had the same question. So what I did, the 380 microPK data, the sequence, and similarly for the sequence of control scores, what I did is I reshuffled them. I reshuffled them many times. I reshuffled them 10 times. And each time I was working out, I applied the Rescaled Range Analysis to estimate in each reshuffled sequence the Hurst exponent. I did it 10 times. And then I estimated the average Hurst exponent. And then I saw that for the microPK, I found 55% on average. So it's in this region. You see, I have destroyed the persistence by reshuffling. In other words, the persistence was due to the arrangement for, according to date of publication. So this is now for sure that the scores published each year were resembling what was published previously. So I had another tool, mathematical tool, which I decided to use. You see, because I have already estimated that the self-transition probabilities in microPK, according to the von Mises model, was 83%, I was able to estimate the first neighbor correlation coefficient in the time series of microPK scores. And what I found was that the first neighbor correlation coefficient was plus 66%, which indicates the strength of resemblance, the strength of persistence between two neighbors, two scores, microPK scores published one next to the other. What is this telling me? That a published microPK score on average mimics the score of the previously published study, regardless of whether it is a microPK hit or a microPK miss. And this is why I found that the two self-transition probabilities were equal. They were favoring hits as much as they were favoring misses, simply because the biasing attitude of the experimenters was to mimic what was published previously. And this is why the funnel plot of microPK data was broadened. Well, I talked about biasing by the experimenters. Now Rosenthal has put it ever so elegantly, saying that yes, this is a phenomenon we know about because it is the unintended influence of the experimenter's hypothesis or expectations. We expect it because it happened previously on the result of our research. But not everyone thinks as kindly about the problem. I have collected, I have seen, there was a surge of publications in years 2015, 2016, because there was a huge problem regarding the replication of studies. Studies were not able to be replicated, and there was a surge of articles discussing it. These studies were mainly in medical science, in biology, and they were also in psychology. And they were saying that we cannot replicate them because there was the scores, the results was the result of fraud. Others were saying, oh, big science is broken, we can't have replications and so on. And there were other articles saying that we are subjected, we are to self-deception, and we produce wrong results, and so on. Now, overall, these publications were saying, in other words, that a lot of published research is false due to human error. It happens. Or outright fraud. It happens. Or anything in between human error and outright fraud. Still, studies, papers prepared containing all these errors and all the problems of fraud and errors and so on were published. Why? Because the reviewers were not able to spot the problem or the errors. And they concluded, these articles, that peer review doesn't work. Well, the problem is not new. And that there has been so much written about the problem of fraud, deceit, corrupted science. The question is, now I'm talking about psychokinesis, but we are interested in all paranormal phenomena. And are we going to allow fraud, bias, negligence to undermine our search for the truth, what really lies behind paranormal phenomena? There are and will be claims of evidence to support psychokinesis. There will be claims that the mind influences some state of a physical system. There will be courses offered to train people in psychokinesis. We have seen there is no such an effect. How are we to understand this controversy? I will make an effort to try to explain it. You see, it takes two to tango. When there is need, there is offer. And how the evidence for psychokinesis is done, we have seen. We have seen what is behind it. But now there's the other side, because there is great need to believe in psychokinesis or the paranormal. We know that a great proportion of people believe in the paranormal, and a great proportion of people have experienced what we call paranormal or psychic phenomena. I am one of them. But here, it doesn't really matter that psychokinesis does not exist and that the mind does not really or cannot really influence physical reality or a state of a physical system. What matters here is the usefulness of belief in psychokinesis. Well, what do I mean? Well, consider belief in psychokinesis, believing that you can have an effect on future events just by visualization, by wishing for it to happen. This is, if you believe so, then you become more self-confident, focused, relaxed, and alert to opportunities. This is a great state of being, and in which we handle our actions with increased effectiveness. And if the right opportunity passes by, then we grab it and make our wishes come true. Psychokinesis in action. Now, I'm not saying this theoretically. I know it is a good state to believe in psychokinesis because I have practiced mind control, visualization to affect future events and so on. I have practiced meditation for many years. So I know so firsthand. And I'm not the only person who believes that a little magic in life is good for you, provided, of course, I have to point out, provided that it doesn't harm anyone or it doesn't affect anyone or harm or exploit anyone, really. Now, the author of this book, which is also available online, says in his book that irrational beliefs, that is, beliefs that are not supported by scientific evidence, like, for instance, psychokinesis, is good for you because it keeps us happy, healthy, and our brain in a good condition. And now I have come to the end of my talk. But before I close it, I'd like to call for further research. You see, I have shown you how I can apply the model of biased binary states and also the rescaled range analysis as a forensic method to understand the mechanism of psychokinesis. But there are other databases available out there regarding the paranormal. I'm aware a few of them, but perhaps there are more, and perhaps more databases can be created just to study, to properly study the paranormal evidence, the evidence for paranormal. I'd like to believe that there will be a positive effect. For instance, it's what I think for Ganzfeld experiments. And what is needed is somebody who's good at computer programming and interested in running such research, and I'll be there to help to apply the approaches that I have described to you. And I'm aware that there are also funding bodies for parapsychological research. So now I have really come to the end of my talk, and there is only one little thing that I would like to say. I would like to pay my personal tribute to one of the best historians of parapsychology that I had the chance to meet, even for a very short while, Dr. Carlos Alvarado. Thank you.